Welcome back to CTO Playbook, the podcast dedicated to helping CTOs excel. In this episode, I'm speaking to Zach Beckman about his Customer Obsessed Delivery Playbook, a flexible framework designed to help CTOs deliver complex software with clarity, structure, and customer focus. We talk about how decades of experience from government projects to iPhone launches shaped this playbook, and why tools like steel threads, event storming, and target state architecture can prevent costly surprises late in delivery. Whether you're at a startup or scaling up, this episode is packed with stories, lessons, and practical advice to help you build smarter and ship with confidence. I'm your host, Adam Horner. As a coach to CTOs across startups and growing companies, I help tech leaders break free from reactive firefighting and build the confidence and clarity needed to lead with purpose. My coaching is hands-on, pragmatic, and shaped around the real-world challenges facing tech leaders today, from aligning with the business to empowering their teams and stepping into their full leadership potential. Through this podcast, I get to share some of the most effective strategies, playbooks, and stories from across the industry. Together with my guests, we explore what it really takes to thrive as a modern CTO and how to shape a leadership path that fits you. Zach, wonderful to have you on the CTO Playbook, and it's really great to be able to talk about the Customer Obsessed Delivery Playbook, which is, of course, your playbook, which hopefully we're going to talk about in depth today. One of the things I'd love to start off with is, what is this playbook and who is it for?
Well, the playbook itself, in a technical way, we can think of it as a set of rules, suggestions, methods for executing a technology development project. But I want to take it up a little bit from that. And just say, look, when you get on an airplane, or if you're a scuba diver, I'm a scuba diver, we all have checklists. Your airline pilot gets in the cockpit, pulls out his checklist, and goes through it. Because of that, aircraft travel is really safe. That's what a playbook is. It's a checklist. It's to make sure that we execute safely, correctly, without missing any important bits. That's it.
And that not missing any important bits was one of the bits that struck me going through the outline of your playbook and the way that it's sectioned up, because I think a lot of the times engineers, architects, CTOs, tech leaders tend to approach projects from a fairly principles first perspective and break things down into first principles and go from there, at the risk of missing something out, not spotting something, overlooking something, or making assumptions. And so is that, I mean, from my experience, it's one of those things that often happens. You get certain far distance into a project and suddenly think, oh, oops, better go and fix that. Now, because it's software, a lot of the times it's not a major problem, but sometimes it can be. What are some of the challenges that you saw and experienced before you had this framework, before you developed it, that spurred you into this idea of, hey, we need to have a checklist for this?
Oh, well, I mean, we can go back to the very beginning, I suppose. My very first job, I started a company right out of college. I was a bright engineer and full of hubris. It was the 80s. I was going head to head with Microsoft, basically. Of course, they were much smaller then. But I made all the classic mistakes. I decided to re-architect 3 different times. I think we started with C, and then we were like, oh, C is horrible. C++. Oh, let's do it in C++. And, whatever the reasons were. We made a lot of mistakes along the way. And that's not something that I just learned every lesson on the first try and then I was perfect in the second job. Of course not. I mean, we learn over time. And, it took decades of experience to get from knowing absolutely not how to build something successfully to building something successfully. Part of that evolution is recording the lessons. I didn't do it the first few times, but pretty quickly I started to realize, okay, I should make a note of that. Eventually, that led to developing a playbook. I liken it to pretty much anything that we do in our day-to-day lives. I love to cook. I bake bread. I probably could make a decent loaf of bread. At least it would be edible, right?
Right.
But every time I go to bake bread, I pull my favorite bread cookbook off the shelf and I follow it. I have little notes in there. invariably I'm going to be flipping back to it and say, oh, was it 500 grams of wheat or 158 grams of water? Or, what? You know, you can't keep every single step and every single fact in your head, no matter how experienced you are at something. That playbook, whether it's a bread cookbook or whether it's a customer obsessed delivery playbook, it gives you that structure, the guardrails, so that you follow all the steps carefully and you have all the, let's call them safety checks, because you'll hit that point and if it's the bread cookbook, it'll be saying, check to make sure your levain is starting to rise, And if it's a delivery playbook, it'll say, make sure that such and such artifact has been created at this point.
One of the criticisms I often come across from the point of view of playbooks when it comes to engineers, engineering leaders, is that there's an element of creativity, and especially process creativity as well as technical creativity, that comes into the innovation aspect of running projects, because we're not running a factory, we're not creating the same output every time, which is what, for example, a bread recipe is designed to do, to have consistency in output. We're almost looking for exactly the opposite of that in many cases, not every case, but in many cases, we're looking for something that isn't just, the expression is cookie cutter, right? Just cut the cookies out of the sheet of dough. In terms of having a process that enables and fosters that innovation, what is it that you've discovered and worked through in your experience that makes that not only possible, but more reliable?
Right. Well, I think two things come to mind. One is that you have to enable your teams to experiment and create their own playbook, really, but to experiment and create at all stages. Like you said, if it is a rigid playbook that says you must follow these precise steps, you may get a certain degree of consistency, but let's face it, software engineering is research and development.
Yeah,
it's not
R&D.
Construction.
Yeah.
And, otherwise, we could just have a step-by-step manual and do it the same every single time. That doesn't mean there aren't important steps we should consider every single time. As long as the team has the flexibility to consider the point and decide what to do with it, that's fine. There may be a particular point at which certain metrics or quality gates or a certain process needs to be put in front of the team so they can look at it and say, oh, yeah, we're supposed to do that here. Oh, but wait, it doesn't really apply. Or maybe we have a better solution in this particular case. That's fine.
Cool. So in some ways, it's more like a playbook recipe than it is like a strict playbook in its own right.
Sure. Absolutely.
I think that's a wonderful distinction to take for it.
Yes. And I'm going to say every good cookbook out there is the same thing. They're going to open you up to experimentation. We don't all want exactly the same bread, right? I love experimenting with it. You made a fantastic cranberry and walnut recipe the other day. It's not in any other cookbook. Made it up. But it was based on a recipe out of the cookbook.
And that's a good thing. Most cookbooks tell you who it's for. Is this for the beginner? Is this for the advanced cook? Is this for somebody who's familiar with baking with sourdough, for example? In terms of the customer obsessed playbook, who would you say it's primarily aimed at? Is there a sweet spot of your ideal customer for the playbook?
That is a difficult question to answer. When the playbook, its very first inception, I had a particular customer profile in mind. I've worked for Accenture twice. I take that as a good sign. I think they liked me. The idea for documenting a playbook probably goes back to my first stint at Accenture.
Right.
They have process for everything. And, maybe it's a little extreme.
That's good consultancies do, though. They want repetition, right?
Right. But there was a strength to it, because if you had the knowledge of where to go in the organization, you could find really well documented process for everything, and you could leverage that. Now, after that, I went to a company called Lightbend. My onboarding experience there was fun. It was kind of like, welcome aboard, figure it out. See you soon, And During the course of my term at Lightbend, I was there about 4 years, ended up as VP of Global Engineering Services or something like that.
And just give us a quick idea of how big Lightbend is in terms of employees.
At the time, there were about 150 people. North America, Europe, they are the company behind Scala and Akka, if you're more familiar with actor model, distributed computing, things like that. And they recently rebranded themselves to be the Akka company. What they do is very niche and very leading edge. We're talking, really high performance, super distributed systems. And it's written in Scala, which is a functional programming language. It's not exactly something that everybody, learns in their spare time. So the challenge for a small company that is a product company in delivering this complicated product to customers like Verizon and T-Mobile and gas, fuel, healthcare, hospitality.
Major household names then.
Big companies.
Yeah.
How do you give them a product like this and make sure they succeed with it without doing all the work for them, right? We developed a model that essentially embedded one Lightbend engineer, because this was not a services organization. They sold product. They didn't want to do consulting, but they needed to make sure that things would succeed.
Yeah.
So we would embed one Lightbend engineer with the customer, the specific goal being to teach the customer how to succeed with this complicated technology quickly. And that's when we started taking the idea of a steel thread, a proof of value that would execute very quickly, show that the work could be done, achieve a substantive proof, very evidentiary, very empirical. We set out to do X number of transactions, distributed environment, blah, blah, blah. Boom, we did it. And teach the customer how to do it very quickly. And that was the evolution of what I had started as a delivery playbook for very large scale Accenture-esque customers.
Right. So starting for multi-team organizations then who have complex requirements.
Right. And then with Lightbend, it became more mid-size, I would say, and then beyond Lightbend in post-Accenture years, turning it into something that could be adopted by literally anybody. And I think that's what it is now. It really is flexible enough and easy enough to consume that it's suitable for startups, it's suitable for mid-size, it's suitable for large-scale companies. Each one will use it in a different way. I have had clients, little startup companies, that have no process. And they're pretty much saying, how do we build software? We don't know. We hired 2 engineers. What's next?
Yeah.
And they just take it and adopt it wholesale. And that's okay. I really didn't intend that, but it works.
Yeah.
And then I have larger clients that use it as a model. Companies that have their own process, they're really looking to discover gaps and inefficiencies and the missing secret sauce. And they can use it as a model to close those gaps.
Right. So they're almost using it like a best practice reference that they can then compare their own internal processes and existing ways of working against in order to make sure that they are not skipping out the bits that you've identified is critical for the generic case of delivery then.
Yes. Very
powerful
true.
Place to be.
Yeah. No, it is. And one of the most interesting things to me that came out of all of this is that while I had started at this sort of path of what are all the pieces, what are all the steps you need to build software successfully? And if you look at the playbook, there's 28 different subway stops on the subway map. One of my customers has taken the playbook and they fell in love with the subway map. They basically ended up saying, you know what? I think we have all the pieces. Our problem is we've got a massive SharePoint repository across so many different departments and nothing ties it together. So the onboarding process is essentially dive into the deep end, talk to a lot of people, kind of figure it out. But then they saw the subway map and they were just like, we need that. We need to figure out how to take all our stuff and tie it together in an easy to consume package that teams can follow. Because right now they look at the SharePoint archive, and they're just like, oh, I'm just going to go Google it and figure it out on my own. Yeah.
And I'm sure anybody who started onboarded into a large organization can empathize with that, because it's quite a common scenario where you come in and they go, right, here's all of our stuff, go figure it out, especially for senior engineers where they think, oh, this person can muddle through on their own, as you say, ending up in a swamp of documentation and trying to figure out where things go. So I do love the subway map. I've got it up in front of me at the moment, and it is one of these circles and lines and multiple different colors of directions, and it makes it very clear where you are and what is most likely to come next, or what the steps are that are adjacent to the steps you're currently in, which I think is quite important for teams in particular, are at a certain stage of development of life cycle and they want to go through. So let's just quickly talk through it, because there's a couple of things I want to come back to. But you've got this idea of mobilization as one section, almost like a zone on the subway map. And then you've got several stops within there before we move over into blueprinting. This is about as linear as it gets, because from there we end up in two different loops, where one is delivery, which is a loop that goes around, and then that also feeds into the other loop, which is operations. So pretty clear in terms of where you are on the map and where you should be ending up as you're going along. But obviously the inspiration for it was a subway map, but what was the moment when you suddenly thought, this is the kind of thing that I need? What gave you the idea to apply a transport map to the idea of journeying through the land of software development?
I'm sure every engineer out there has seen different forms of flowchart describing the development lifecycle in one form or another. I happened to see one that was really oriented on product discovery. We're talking early stage requirements and event storming and getting with your customer and figuring out what it is you're building.
Yeah.
It was a subway map. It was easy to read. I found that, the customers who came in and sat down and glanced at it, you didn't have to say, let me explain how to read this complicated flowchart. They were just like, oh, a subway map. Okay. Where are we on the map? Oh, we're right here. Okay. I get it. Yeah. I rode the subway here today, and then it was like, okay, well, that's got to be it then. Right.
That's quite amazing. The subway map, for those people who are not that familiar, was something that was innovated in, I think, 18 something or other in London, in the UK, to describe the then growing London Underground train network. That's a simple innovation. It used to have a lot more detail on it, and it's been simplified over the years to the point now where it's, as you say, pretty easy for anybody to look at and go, I can see where I am, I can see where I need to go to, and the colors tell me which lines I need to go to get there. So I think that's a wonderful story of how you get from where you are in terms of a set of steps and probably a list, maybe even a hierarchical list, to something that's a lot more visual in terms of representing it. But I'd love to just take you back, Zach. You've been working on this for many decades. What were the signs that you needed something like this when you were working on projects? What were the warning signs? What were the challenges? What were the things you had to overcome? You mentioned just writing things down, but where was the step where you sort of went from that to be, okay, let's actually map out the whole thing?
Yeah. I don't think it was a single point in time, but I do remember, in particular, I guess you could say my decade or so in the periphery of government and the Defense Department, to say that it was normal for projects to go over budget and run long was, I can't even think of any that I heard about that were remotely on time. And I thought it was horrible because everybody knew that it was going to go over budget and it was going to go long. And it's not to say that everyone didn't try, but it was just this level of apathy or acceptance that, I'll do what I can, but, this is the way it is. This is software development. And there was this conflict with, let's say the customer. Now, was the customer a government agency or was it a customer that you're trying to deliver a product to? It doesn't really matter. Whoever's paying the bill, they didn't like this. But there was this miscommunication, this misperception.
Right.
Whoever the customer was essentially saying, look, I can go to the car dealership and buy a car, and I know how much the car will cost, and I can even order a car with a special paint job, and they'll tell me when it gets here. Why can't you do that with software? And then you have all the engineers being like, well, we've never done this before. We're trying to figure it out. And my wife works in the biopharmaceutical industry. Things are very different there. Research and development is understood to be an unknown. There is, of course, a push to put reasonable guardrails on things so they don't go forever, et cetera, et cetera. But to go to a pharmaceutical company and say, hey, we'd like you to invent this new medication that's never been developed before. Could you do it for, say, $500 million and have it done by the end of next year? Of course not. Nobody knows. It's never been done before. So to me, what really seemed to be missing was this understanding that the endpoint is unknown. But as we approach the endpoint, we learn more and more. The field of possibility gets narrower and narrower.
Right.
You have to have a starting point where everybody comes into the room and says, we don't even know what we're building yet. So it's silly to talk about how long it will take. But we're going to refine that. We're going to work together. And as we refine it, we're all going to be on the same page about how much certainty we have. Until you get to a point where the business can say, we understand there are certain variables, but we've seen it go from this really wide, who knows, down to this area, and we're comfortable with that, right? So I think that was an evolution that probably took 10 or 20 years for me to go through, starting with some of those horror stories in the Defense Department where we were years over schedule.
And often those things are caused by, well, you mentioned miscommunication, but I think also missed steps, aren't they? Where somebody forgets to assess risk or to look at the security profile or something like that until they get up to it later and go, oh, by the way, we need to add in the ability to credit ourselves against this security accreditation, for example.
Yes. Well, I have a favorite blog post on my blog that talks about why we started measuring software the wrong way. It goes to the inception of the waterfall model.
Yeah.
And it's an interesting read because it actually shows that the inventor of that model came to the conclusion that it was a bad model and should never be used. But then, of course, the industry went on to use it. So, that just gets back to, can we apply industrial construction process to a research and development setting? Of course not. What we can do is measure and checkpoint all the way along the course. And that's really what the playbook does. If we dig into every single subway stop on the subway map, each one goes down into a chapter, but each chapter defines inputs, which were generated previously, and then a bunch of activities and outputs. Those are your quality gates. You have to have the inputs, otherwise you can't proceed. You have to generate the outputs, otherwise you're not ready to proceed. Right. And so this is just a basic definition of ready, definition of done. Yeah. But it's applied to the whole process. It's not just a genericized, did you run your unit tests?
And I think the key thing is that it covers not just delivery or the creation of the software, but also the understanding of what it is that's needed. I mean, there's a couple of things that you mentioned there that I'd love to dig into further. One of them was the steel thread, which we'll come back to in a minute. But the other thing you mentioned very quickly and in passing was event storming. As far as I know, it's not something that's used that widely to help with product understanding and requirements solicitation. So could you just talk a little bit through event storming, how you first came across it, how you've seen it used really effectively, and quick start off with just what it is first?
Sure. To the best of my recollection, my first exposure to event storming was once again back at Accenture. This was a huge project. It was in the cruise line industry, modernizing cruise ships. And
the industry then.
Definitely. And a fascinating problem too, because people don't, I had no clue until we started this project. But if you think it through, a cruise ship is a small floating city, 5,000-ish people on a cruise ship. It's moving around the world. It has limited connectivity, and yet it has to continue to function even when it is in the middle of the ocean and has no connectivity. People are on board. They're booking excursions, buying meals, gambling, planning where they're going to stay, and presumably booking rooms in China or whatever the destination is. The ship has to make sure all that happens smoothly. So it's a pretty massive computing platform. And then as it drifts around the world and connects, disconnects, reconnects, it has to synchronize. And all these events that happened on board the ship and that happened off the ship on land or other ships, they all have to kind of marry up and agree. And that gets us back to eventual consistency. The world is eventually consistent. This is how the physics works. And it's how the physical world works. And we need to be able to model our systems thinking in that pattern. Event storming is a way of rationalizing about what we're doing using eventual consistency, because we're basically just mapping out a sequence of events. I like to do an event storming exercise by sitting down with everybody in the room and saying, okay, pick on whoever it is I'm picking on. Maybe it's somebody who takes care of booking the reservation on a cruise ship. Why don't you just explain to us using these Post-it notes what your day is like, or what it is like to book a reservation. I still remember that because they took a stack of Post-it notes, a whole brand new stack, and started modeling out. Well, first, I give somebody's name, and then this, and then this, and they ran out of Post-it notes.
Wow. Okay.
Yeah. And we're all just thinking, you're still just booking the reservation? It created so much mind share. Everybody was like, wow, okay. That is a whole new level of complexity. And that's really important. The engineers and the customer need to have this shared mind state. Otherwise,
right. So this isn't just with engineers in the room or product people in the room. This is business folks, your customer. This is process people, as well as engineers and product folks all together, getting that same context at the same time. I think it's one of the key things about the event storming, especially when I've done it, has been the idea that everybody hears it from the source at the first time and can ask all those awkward questions. What happens when this? What happens when that?
Yeah, exactly. And it's really powerful when everybody is in the room. It has to be that group exercise because you'll get the customer saying, oh, well, and then I capture the travel information, one Post-it note. And an engineer is like, what's that mean? Travel information? Oh, well, we need their passport. We need a photo of their passport. We need their passport number. We need their vaccination records. We need engineers like furiously writing all this down. So what? So again, then we model all that. It's like, okay, that's not one Post-it note. That's like 10 Post-it notes. Let's get them all up there, please.
Cool. So very powerful process. And that brings, I think, the sort of the idea of what it is we're going to build to a common state. And I think one of the other things you mentioned, which almost follows on from that, is the idea of the steel thread, which is, well, what is the steel thread? Talk us through what the steel thread is, because I think it's one of these interesting concepts that's been brought over from a completely different industry, manufacturing, and brings this idea across. Just talk us through what it is.
Sure. So the name comes from, it's an analogy. If you want to build a bridge across a chasm, step number one is to fire a steel thread across the chasm, secure the steel thread on both sides. And then effectively what you can start to do is build your infrastructure off of that steel thread. And as you need to, you can bulk up the infrastructure. But the analogy is that you actually do cross the chasm. That's your objective, your business purpose with that very first action of firing a steel thread, which involves several steps, but in a way, architecturally, it involves all the major pieces. You're going to have to secure on both sides of the chasm. You're going to have to build a structure across the chasm, even if it's just a taut thread, stuff like that. So what we want to do is effectively achieve the same thing with software. It's a little bit different than saying, oh, well, this is just being agile. There's a couple of really important differences. The objective with the steel thread is, first and foremost, to prioritize your highest risk items immediately. So if they're hard and if they're unknown, you try to effectively prove them in 1 or 2 sprints. The other thing is, you're not setting out to build anything in any remotely complete fashion. Instead, you're trying to build everything in an incomplete fashion in this initial iteration, so that what you have at the end of a very short steel thread, we're talking 2 sprints, maybe 3 sprints at the beginning of a project.
Yeah.
You will have stood up all the pieces that are required for the technology foundation. So if you're building an event streaming system, you'll have an event stream. It might just be a simple little Kafka instance with one topic. It's not tuned, nothing, but you can drop messages into it and you can pick messages up. You've proven that the event stream works, right?
So it's not so much an MVP then, it's more of an end-to-end proof that the scaffolding for the ultimate solution will hold together.
Exactly. It's definitely not an MVP. It's nothing you could ship, but it is a proof of value or a proof of concept.
Yeah.
What you want to do coming out of it is say, we took all the big unknowns and we turned them into knowns, and we tied it all together. And we now have confidence that we've eliminated the major risk, hopefully all of the risks that we really feel could derail the project. And we've done it in 2 or 3 sprints. This goes back to what we did at Lightbend with our embedded Lightbend engineer.
Right.
We had one project. It was one of the 3 major telcos. I won't say the name, although if you Google it, they actually did a really nice on-stage presentation and all that, so it might be okay, but I'm going to avoid the name. This is, I think the era was the iPhone 8 or 10. Every single telco would have these iconic iPhone launches. It's on sale at midnight. Midnight and 2 minutes. Up until this year, every single telco, their systems were falling over. Some of them were crashing. You had them losing customers, abandoning the shopping cart, going to a competing telco.
Just because of the sheer quantity of demand for it.
Yeah. You had everybody piling on. And so 2 months before the launch, we went to our telco client and said, look, we believe in our technology so much that we will come in and build the solution for you free. We're going to bring 3 or 4, I think it was four of our team. And we need 1 of your team from your development unit. So we're talking about 8 people.
Yep.
Total.
So quite a significant number of people.
Yeah. We're going to build the solution to this problem in approximately 6 weeks, because that's when the launch was. The launch was 2 months out.
Fixed deadline.
And they said, that's absolutely impossible. Ridiculous. Our team says it'll take 9 months minimum. We said, well, you know what? We're going to do it for free. And if we fail, you don't pay us. So they said, okay, fine, come on in. And we did it. And they went live, and they were the first telco to not suffer a failure on the iconic launch that year. Steel thread.
Really went on to a lot of follow-on business, but it was that steel thread that was the initial delivery that gave the proof that you could solve the problem within the time frame.
Yeah. And our steel thread was effectively, we need to be able to handle this number of transactions without failing. And then, like you said, from there, it led to a nice license and a lot of follow-on business, et cetera, et cetera. But that core of we just have to take the order and make sure the system doesn't fall over. That's it, And
that's great.
It was an exciting project, and it was even more exciting to see how successful it was.
Because I've often done proofs of concept, and I've often stood up, DevOps systems that allow automated deployment, but to tie the two together into this one idea of we're just going to get all the way across the canyon in one go, even if we're sort of, doing it in a very basic way, and then hang everything else off it as we build afterwards, I think it's quite a powerful approach to take.
Yeah, I won't do a project without it, if it's at all within my control, simply because the awareness that it gives you is so powerful. You've heard about so many projects, I'm sure, you're in the 11th hour and suddenly there's some big discovery, something that we didn't figure out until the last minute. That's the thing that you should have figured out in the steel thread.
And I think that's really powerful. And often when you start out with that steel thread, I think one of the things you need is a very clear idea of what it is that you're solving. And so one of the things you talk about in your approach is this concept of a target state architecture. Now, I've built target architectures before. In fact, I once joined a fairly major rewrite of a company's main product. And within the first couple of weeks, did a quick sketch diagram on a whiteboard that 18 months later, when we actually crossed over to the final solution, one of the team brought that out and I was a little bit embarrassed at the time. And then they went, oh, look, what we built is basically the same as this diagram from 18 months ago. I was like, great. So a target architecture does actually work. But you've got this idea of a target state architecture. Now, what I'm wondering is Is there much difference between what I've just described and what you're talking about with the target state architecture, or is it more all-encompassing than that?
I think there is a little bit more to it. And probably the heart of it is that a target state architecture is what you are aiming for in your future state. There's a difference between we've designed this monolithic, maybe it's not monolithic, but we've designed this all-encompassing architecture and it's one thing that we have to do versus we've designed the long-term future target state and we are here now. And there is a path from here to there. And we need to recognize that we can get there incrementally and in a sane manner.
Yeah.
When you look at the whole picture and you don't tackle it piecemeal, you can very easily pull things in from the far future that you're pulling it in too soon. And it jeopardizes your near-term objectives by introducing risk, by introducing complexity, by introducing scale. I very much believe in iterative, agile, not particular style of agile, one versus the other, I don't care. But
agile with a small a.
Yes, but the ability to adapt and shift and not ship the whole thing in one big bang at the end. Instead, let's figure out what that small slice is and let's ship that and let's try it out. And let's see how the customer likes it. And then let's iterate and grow on that. Right. I think that's really the heart of having this target state architecture with an idea that it's something we evolve to over time.
Yeah. But also I think there's in there this idea that we're going to iterate to it with an appropriate level of risk and ambition at each stage of it and avoiding the big bang approach of either migration or cutover.
Yes. There are a number of situations where I've had customers come in and say, here's all the features we need. And you look at each of these features and you're like, wow, those are big, complicated features. And each one carries a lot of risk. You need to be able to say, look, we're not going to tackle them all at once. We're going to take one of them and we're going to tackle that one and we're going to ship that one. And then we're going to reevaluate and look at all the other features we're talking about. We'll tackle them in sequence or, maybe it's a couple at a time or whatever. But if you try to do it all, suddenly you're taking all that risk on right up front. There's no way you can guarantee any rational level of success when you take on that kind of complexity right out of the gate. It's got to be
that the world changes and customers change and the customer focus changes over that time as well.
Absolutely. And I've seen many customers where the big long list is completely different by the time you get to the end of the project, because you allowed for that evolution over time.
Yeah, and I'm sure we've all seen the number of customers who've at some point, or some number of development teams, I should say, at some point decided to throw away the backlog, the infamous graveyard backlog, because of the fact that the world changed, everything shifted underneath them. So, I mean, one of the key things in Playbook is basically the customer obsessed aspect of it. So, how generally do you keep the customer view and vision in sight at all times through your process? How do you sort of de-risk that?
Right. Well, at a macro level, the customer needs to be involved throughout the whole project. But that's easy to say. So how do we do it?
What does that look like? Yeah,
we can start in the early requirements gathering evolution of the product using tools like event storming, where we've got the engineering team, we've got the customer team, we've got the business analysts, we're all in the room together, developing not only a common understanding, but a documented understanding of what it is we're going to do through these event maps. Then the key becomes using those as engineering artifacts moving forward so that as you're developing more detailed technical artifacts, you're not distancing yourself from the source, which in this case would be an event storm. You're actually incorporating the event storm and expanding upon it so that you avoid the telephone game, the translation errors of we got the requirement statement, which we translated into a given when then statement, which we gave to an architect who turned it into some kind of technical architecture. And then the QA department did their thing and then the customer got the product and they said, this is not what I asked for. Yeah, you want to avoid that by making sure that event stream is always in the line of sight through all your artifacts. So the way I developed the engineering artifacts of the delivery playbook, we're adding fidelity to the event storm by going from an event storm to a tactical event storm, which is basically taking the original event storm, which is a customer artifact, adding more fidelity to it. And then we take that to the engineering level. I like marble diagrams and sequence diagrams, but it doesn't really matter. But again, you're taking the original artifact and expanding it, but you're still maintaining that original artifact in your design drawings and whatnot. So when you're actually at the end point and you've got this much expanded technical design, you can pull it up and you can sit down with the customer and they can look at it and they can say, yeah, I see my event model here. I get it. And I follow everything you're doing down to these technical details. And it all still flows together. It's still one solution.
So it's keeping yourself on the same page by using the same overall artifact to understand the customer and where they're coming from.
That, as well as making sure that you're measuring exactly what the customer wants measured.
Right. Yes.
And that gets back to your acceptance criteria, which have to tie in with the event storm. The event storm is going to show you, I captured the customer travel details, and then something happened as a result of it. Well, this something happened. That's your acceptance criteria. That's what you have to test for. So you kind of end up with this, the customer told me they do this. I do a whole bunch of stuff, and it comes back up here, and I test against what the customer wants to see.
Yeah.
Right.
Yeah. I can absolutely relate to that. I think in my second startup, it was when I was actually a founder of it. We made this, what looked like a really risky pivot. And yet me and Stephen, my co-founder, we basically, well, this is a no-brainer for us because it was exactly what the customers were asking for. So we did this pivot, which, yeah, it looked crazy on the outside, but it became the foundation for pretty much everything the company does now, still to this day. And so therefore, it didn't end up being this scary gamble in the end. It was actually what is the foundational source of value in the company. So I can definitely attest to keeping the customer front and center. But let's try and make the roadmap front and center for our listeners. What is the easiest starting point to get going with this? So if somebody was to just take the core ideas that we've spoken about today, what would you say are the first simple steps that a CTO could take to implement your core idea of running things in a predictable way to make a significant difference to their own projects?
I think one of the most important things is teams need to create their own process. They need to have that freedom. I've never seen a committee designed process succeed. Maybe it's a decent starting point so that you can say, okay, here's all these little checklists and things, and we can begin there. But the team needs to have the flexibility to say, that's not going to work, and we're throwing this junk out because it's silly, right? A team will be successful with a process they design themselves. And also you want their research and development capabilities to be enabled. They're here to invent stuff. And that doesn't just mean invent product. It also means invent better ways to deliver product.
Invent the process.
Yeah. So they need to be the process here, right? The other thing, as a CTO, working with my team, I am ruthlessly empirical about measurement. Whatever we're trying to build, I need to know how we're going to prove that we succeeded up front. Quite often, engineers will be like, what does that mean? I'm like, okay, keep it simple. Let's track it back to the dollars, right? There is going to be a business behind this product, right? In order for the business to not go bankrupt, we're going to have to make money, which pretty much means everything that we do. And I know this sounds, very capitalistic and all, but it can be tracked down to that particular feature has a certain value, and we should be able to measure it. Sometimes it's super easy. It's, oh gosh, we have too many servers. Our objective is to cut server infrastructure by 50%. Okay, super easy to measure. What about, we want our customer to be happier on our website? Trust me, it can be measured. Yes, it's harder to measure, but it can be measured, right? So we've got to be able to measure success. and then not ignore it. If we're halfway through the delivery playbook and we start to see that the measurements are not lining up, don't say, we'll fix it later. Oh, we're only off by a little bit. No. If you said this was supposed to be the outcome and it's not, you have a problem. Time to deal with it. Finally, the customer has to be at the table all the time, every single time. Those are was that 3 things? I'm not sure.
Yeah, that was 3. 3, very straightforward, and I think very, very fundamental. So just to summarize then, own the process in the team, measure the dollars, and don't ignore the numbers when they start drifting from your targets. The customer must be at the table all the time. Pretty straightforward approach to building stuff. Cool. Zach, it's been wonderful to have you. Thanks very much for talking us through the playbook, through some of these wonderful concepts that you've been using to put it together. How can people reach you? What's the quickest and easiest way to reach you personally? Are you available on LinkedIn, for example?
I am on LinkedIn. Zacharias Beckman is a relatively easy way to reach me. You can also go to blog.bosslogic.com, and there's options there to reach out to me directly. So not too hard to find.
Excellent. Good stuff. Thanks so much for your time. It's been wonderful to talk to you, wonderful to learn about some of the steel threads, the event storming, and the way you put it all together. Yeah, something that would be a scuba diver would be proud of in terms of a checklist.
Thank you very much. It's been an absolute pleasure, Adam. Appreciate the opportunity.
Thank you very much for listening all the way through to the end. Just before you go, I'd like to ask you for one thing in return for putting together all these episodes of the CTO Playbook podcast for you. Please leave a review. Wherever you're listening, whether that is Apple Podcasts or Spotify or whichever platform you're on, leaving a quick review will help more CTOs find the podcast and enable me to create more great episodes. Thank you for listening, and I'll see you on the next episode of the CTO Playbook.